And now it is my pleasure to introduce our presenter for today, Heather Himmelberger. Heather is the director at the Southwest Environmental Finance Center at the University of New Mexico. And at this time, Heather, I will turn the program over to you.
Thank you. Good afternoon, everyone, and happy St. Patrick's Day. Well, it's another beautiful day here in Albuquerque, but it sounds like winter is still going pretty strong back east, so I hope you're all doing okay and snuggled in nice and warm if you're back where the snow is still falling. And I'd like to welcome you all to today's webinar, and I'd like to thank the Syracuse EFC for hosting and recording today's webinar. This webinar is part of the Environmental Finance Center Network's project that we call Smart Management for Small Water Systems. This project is funded by EPA, and it allows us to provide managerial and financial capacity assistance to small water systems all across the country. In this context, a small water system is defined as one serving 10,000 people or fewer. We have provided a series of in-person workshops on asset management, rates and finance, energy efficiency, water loss, access to funding, and water system collaboration. Hopefully, some of you were able to attend one of these in-person trainings. As part of this project, we are also holding webinars in most of these topic areas to accommodate individuals who are not able to receive in-person training or who were interested in an additional topic other than what was offered in their area. Today's webinar is part of the Strategic Water Loss Reduction series of webinars. The first webinar was focused on understanding the problem. Today's webinar is focused on strategies to address real water losses, and the third webinar will be held on March 31st and will focus on strategically applying water loss reduction strategies. Essentially, that webinar will be talking about how you decide what the best options are for your particular system. We hope that you are able to attend all of our webinars for this series, but if that isn't possible, it's okay because each webinar is designed to be standalone. And also, if you miss a webinar, you can always access the recorded webinars online at the EFC Network site, efcnetwork.org. And in addition, any of the other webinars for any of the other topics are also available online there. So if you want to listen to a webinar on any of the other topics, feel free to go ahead and access those recordings. Right before we get started, I'd just like to show a geographic distribution of today's attendees. And the maps that you see show that we have people pretty much all across the country in Puerto Rico, Hawaii, Alaska. So again, welcome to you all, and I hope you enjoy today's webinar. And just as a reminder, if you have questions as we go along, feel free to type them into the chat box as we go, and then we'll get to them at the end of the webinar. Just a quick review from our first webinar. This equation might look familiar to you. Water produced minus water sold equals water loss. So the big question is, what does that water loss value actually represent? That water loss value is more than just water that's leaking from the system. It's actually what we call non-revenue water. So it includes 6 different purposes. Water used for city, town, municipal purposes. So this is water that you're not billing the city for, but they might be using it to water parks, fill in swimming pools, water gardens, a fountain, anything like that where you're having the municipality or your town or your city, your community using water that you don't bill them for. Also, firefighting would fall in there. So any of those kinds of uses sort of fall in that category. Illegal water use. If somebody has tapped into your hydrant, or tapped into your system illegally and is using water without paying for it, that would be included in this category, as well as, commercial or industrial customers who might connect up to a hydrant and take water that way. Water that's used by the water utility for flushing or other purposes falls in this category. If you have any inaccurate meters, your customer meters, they typically tend to read a little low as they age. So those meter inaccuracies will show up in this number. If there's any issues handling your data, reading the meters or how you enter that information into the system, or any of those types of data handling errors, that will show up in this number. And then finally, the subject of today's webinar, the lost water, the real water that's being lost to your system, is also a component of this non-revenue water number. So the way we kind of get a handle on what is making up our non-revenue water is we do a water audit, or a water balance. And one of the best tools for this is the American Water Works Association Water Audit Tool, and it's available for free on their website. And everybody who's attended any of the water loss webinars will get information on how to access that free water audit tool. And you can go online, and it's got a tutorial. It's got some information on how to use the tool. And then we also have available on our website, efcnetwork.org, a guidebook that kind of helps you through how to get the numbers to enter into that water audit. So we have a companion piece, and again, we'll send you information about that following the webinars so that you can get on and do an audit if you would like to. So what we're really focusing on for the non-revenue water are these categories at the bottom here. And today's webinar specifically will focus on these categories of non-revenue water, the ones that have to do with real water losses, real water leaving the system. The other part of that category is water that's non-revenue generating, but it's not lost to the system. So why do we care about real water losses at all? Well, one reason is limited water resources. So about a couple of years ago, there was about 40 states out of the 50 that were in a water shortage or a drought condition. Many states are still in drought today. It kind of depends on the state, whether you're in or out of drought. But most states at one time or another experience a limited drought. Some experience a longer drought. And because the water resources can be limited, we really want to make sure we're not losing very much water out of our system. We can have hazards related to water losses from our system if water's leaking on the surface. We can have ice or ponding or hydroplaning that might occur. So we want to try to prevent those kinds of things from happening. With the increasing costs of producing water, including our increased energy costs, it costs us a lot of money, or it might cost us a lot of money to make our water, so we don't want to just waste it out the pipes in our system. We want to make sure we keep as much of that going to our customers. There can be water quality impacts related to leaks from our water system. If we have any leaks in the system and then we have a pressure reduction happen and we could potentially suck something into our pipes, we don't want to do anything like that. So we don't want to have any water quality impacts from the leaks, or if we have a major pipe burst in our system and it collapses and something falls in the pipe that way. We want to try to prevent those kinds of things from happening. It can be an inconvenience to our customers if we get a major leak. We might have to shut a lot of customers off. We might have to block the street while we fix it. The street may be out of service for a while. And then finally, damage to property or other utilities. So as the water loss occurs, and if we get a catastrophic failure with maybe a sinkhole or something, we could have damage to a road. We might have damage to sewer pipes or other utilities that might be in the same area of our water utility. We might have damage to personal property. So for all these reasons, we really do want to think about real water losses from our system and what we can do to try to minimize those losses. Real water losses come in 3 different categories. First, leakage on mains. So this is all those pipes that are transporting water around your system, moving it from your wells or your surface water sources to your tanks, to your customers, to your industrial customers, residential customers, commercial customers. All of that piping network that's moving water around your system, that would be considered your mains. So the first part we're thinking about is leakage in any of those types of pipes. The second is leakage on service lines, and in this case we're thinking about those pipes that connect your mains to your customers up to their meters. So we're not thinking about what happens from the meter back to their house. That's a whole different category that doesn't actually show up in this type of balance. But we're talking about what connects your mains to the customer meter. And then finally, the last category is leakage or overflow at storage tanks. Leakage or overflow at storage tanks is a little bit different than leakage on pipes, so we're not going to spend much time talking about this today. We're going to mostly focus on the pipes. It's also handled in a different way. If you have an overflow at a storage tank, you want to make sure that you think about why that's happening. Are you overfilling the storage tank because maybe there's something wrong with the equipment that's telling you what what height of water is in the tank. Are you, do you have some operational problem, a design problem? Is there a malfunction in the tank? And you want to try to investigate what's going on with that tank so you can stop the overflows and the loss of water that way. If the water's leaking out of the storage tank through some structural problem, there's a hole in the tank, something like that, you really want to address that because you don't want any holes in your storage tanks. That's a very dangerous thing and could be a public health protection problem where you don't want anything from the outside washing over the tank and getting into a hole in the tank and then getting into your finished water supply. So again, the storage tank would be handled a little differently. The overflows, you want to look more at the design and operation of the system, the functioning of your level detectors and things at your storage tank, and the leakage at your storage tank. You want to just inspect the tank very thoroughly. You want to make sure you really are have a tank that structurally has good structural integrity and no leaks. So handle that sort of separately. And the rest of the discussion today is going to focus much more on leakage on mains and leakage on service lines. So the different categories of water loss, we want to think about what our total water loss amount is. And this is real water loss, not that whole non-revenue water. This is just the real water being lost to our system. So we call that the current annual real losses, or CARL, C-A-R-L. So that green box is sort of representing all the water that's being lost to the system. And then within that green box, we have something we call unavoidable real losses. These are the losses that we feel like we cannot remove these, and we'll talk about what causes unavoidable real losses. So what we actually have a chance to do something about is the area that's sort of hatched in the purple lines. So if you look at all of this area out here, outside the red box, this is all the potential to reduce the real water losses. And then we have one more consideration, and that's economics. Because although we could reduce that whole hatched area out here, it may not be economically feasible for us to do so. It may cost us too much money to reduce all the losses, so we may have this yellow box that says, well, we're only going to reduce this many losses because that's what's economically justified for us to do. Now, I couldn't tell you what the economic level of real losses is for each system because it's very system specific. You have to go in and look at your particular situation. How much does it cost you to produce that water? How much does it cost you to or what are you selling that water for? What would it cost you to reduce the losses? So you can do a cost-benefit analysis and say, it would cost me this much to reduce it, and it would save me that much money if I did, so what's economically justified? And it's always available to a system to do more than what's economically justified. If you're in an area where water resources are very, very precious, you may go well above the economic level just because there are other reasons you're justifying it. But it's important to remember that there are these different levels. There's the current losses that encompass the whole real water loss. There's the unavoidable real loss that we really have more difficulties dealing with, and then there's what's economic to reduce. So to look at what is our unavoidable losses, that's really our background leakage. And this is leakage that occurs primarily in joints or fittings. And it comes about because as the pipe ages, it experiences different kinds of pressures and vibrations, and depends on how deep the pipe is and what kind of construction you had and how tight the system is. So the background leakage is things that we're just dripping water out of connections. So if you think about maybe at your house when you connect a hose to your hose bib at your house, and initially you get it nice and tight and there's no water leaking, and then a couple of months go by, or maybe even a couple of weeks go by, and you start to have little drips out of that connection. There's nothing wrong with the faucet and there's nothing wrong with the hose. It's just that the vibration and the pressure and all that from turning the hose on and off and all those types of things have caused them to separate a little bit and have some leakage. And that's kind of similar to the pipe, where the pipe may be perfectly fine. The connection, physically is fine, but it's pulled apart a little bit, and so we have a little bit of leakage. So we just consider that to be normal and part of the whole water moving pipe process. Next, we have our unreported or detectable leaks. These are leaks that we don't see. We can't observe them, but they're there. They're hidden from us, and they're creating a leak within the system, but we don't see it. And then the last category is observable leaks. These are things that are reported to us. We're aware that they're happening, and we can see them. So it's water that maybe is dripping down or is running down the street. Perhaps you found it because there's green grass and it's an arid region where you don't expect to see green grass, or you see, maybe you feel the ground is kind of sloshy because there's a lot of water there. It's anything that you can see the water coming up from your pipe to the surface. So we call those reported breaks or observable breaks. Now, the way we would address real losses is we have 4 different strategies, major strategies that we can use. So the first one is respond faster to leaks that we know about. The second is asset management. The third is to reduce pressure. And the fourth is to find hidden leaks. So if you notice the same green box that we looked at before that constitutes all the losses you can have, you will notice that these 3 arrows push in towards the box, meaning that if you do these 3 things, you can reduce the size of that overall green box by reducing water losses. But you might notice that pressure management has an arrow going both ways. The reason that is because with pressure management, if you reduce the pressure, you'll reduce the size of the green box. But if you increase system pressure, you can increase the size of the green box. So that's one area where it can actually go both ways in terms of losses, where the other 3 are trying to have a positive impact on your water losses. So let's go through each of those in more detail. So responding faster to known leaks. This is trying to get out there when you know about a leak and fix that leak sooner. So we have a poll question for you here. We're going to put up a poll question that shows 5 different types of leaks. If we could go ahead and start the poll question. Okay, so we have 5 different kinds of leaks here that you can pick from. And the question is, which leak do you think would have the highest total water loss? So we have 500 gallons a minute for 4 hours, 200 gallons a minute for 2 days, 50 gallons a minute for 4 days, 10 gallons a minute for 45 days, or 5 gallons a minute for 100 days. So select the one that you think would have the highest total water loss. And you can just take your best guess. You don't actually have to go through the math to figure it out.
We've got lots of folks providing their responses, so I'm going to give them a few more seconds. Okay, and at this time I will close the poll.
Okay, so we had a lot of people either really smart or doing the math for us. So we have 85% of the people that have picked 5 gallons a minute for 100 days, and then 7% picked the 500, and then 5% the 200, and 4% the 10, and nobody wanted the 5 gallons per minute for 4 days, or 50 gallons per minute for 4 days. So if we can close the poll. So what many of you figured out is here's the leak quantities if you actually do the math. So if you look at your 5 gallon per minute 100-day leak, it produced a water loss of 720,000 gallons, whereas the very major leak, although it's huge leak, it was a short duration, so 120,000 gallons a minute was produced out of that loss. What this is all about is looking at if you could cut the leak time in half, how much water could you save? So if we could respond twice as fast as before, so each one cut down in half, we could actually save 1,176,000 gallons for these 5 different break types. So the point here is if you respond faster, you do have the potential to save a lot of water loss. So we really want to make sure that we can respond as quickly as possible to the breaks that occur, because ignoring a slow leak because we think it's a small matter and it won't make that much difference, we want to try to change that thinking, because it is important to think about how much loss comes from a small leak. So another poll question is, what reasons do you have for why you haven't repaired leaks sooner? What kinds of things happen in your system that make it more difficult for you to make repairs in a timely fashion? So you can select all that apply this time. So we have maybe small leaks that don't matter that much. So, you kind of think along the lines of, well, if it's a small leak, we don't really have to get out there very fast, or insufficient staff, inadequate resources, maybe we don't have enough money or equipment or supplies. Maybe we have other priorities, prioritized by myself or management, where you have other things that you have to do and you can't get to water losses. Or you have a large water supply, meaning you have a lot of resources and you're not too worried about water losses because you have that big water supply. So take a few minutes and just click the ones that you think best describe your system and why maybe you don't fix leaks more rapidly. Okay, so it looks like some of the biggest reasons are insufficient staff, which I can imagine is a very big reason because a lot of systems are really short-staffed. Inadequate resources, lack of money, or other priorities. Those seem to be things that we hear a lot of in lots of other contexts as well. But those are major things that often prevent us from doing other parts of our job as well. So we can go back to the slides now. So maybe think about if your system has a lot of smaller losses and it does take you a long time to get out to fix them, maybe think about what kind of case you might be able to make to be able to have a more rapid response. Maybe you can make your case to your decision makers, the people that have the budget in hand, or your managers, the people who tell you what to do during the day, to make a case for maybe getting out there a little faster. So the kinds of things that you can use are small leaks adding up to a lot of water. We talked about that in the prior poll about how important it is to realize that small leaks can add up to a lot of loss. Your system integrity is compromised as long as you have leaks going on, so you want to try to fix them as soon as possible to avoid any problems that might be related to public health. We want to avoid a more serious and expensive repair later. If we fix it now as a small leak and do it quickly, we might be able to avoid having a much more expensive repair when a sinkhole occurs or when a catastrophic failure occurs, because some research has shown that many times those catastrophic losses occur, start out as a very small leak and then grow bigger. So we want to try to fix them before they grow bigger. And it's less expensive to repair pipe than to replace it, and if we get out there sooner, maybe that can help us avoid having to replace pipe. And then over the long run, equipment and training will pay off, and you can try to help collect some data to help make your case that that is true. So you can look at what is the full cost of your water production. What does it actually cost you to produce that water? So every drop you're saving is cost savings in terms of water production. You can estimate how much water is lost through delays in fixing leaks, similar to what we did in that poll, after the poll where I showed you, if you cut down the losses by so many days, you can start to make that kind of calculation on your own by estimating what your water loss volumes are and how long you let them go from the time of first being found until you can fix them. And then you can sort of put some of these things against the cost of additional staff, the cost of the additional equipment or supplies you need, and then you can think about, are there any non-economic benefits that you're getting? Are you reducing the amount of downtime for customers? Are there any other non-economic benefits that you can kind of put a value on? And do a little cost-benefit analysis for your decision makers to try to show them that doing leak repair faster will ultimately be beneficial to them and worth the investment into the time, equipment, personnel, whatever it is you need to be able to do that quicker. The second part is asset management. And just a quick review of what asset management is all about. Asset management is a process where we look at what assets we own, we take an inventory of those, and we look at their condition, how much longer they're going to last in the system, and we make an inventory of everything that makes up our system. And then we decide what it is we want our assets to do. We set a level of service. saying, what is it that I want to give my customers out of my assets. Third is criticality. This is where we look at each asset and we say, what is the probability that that given asset is going to fail? And if it does, what is the consequence of that failure? And this helps us focus on what are the highest risk assets in our utility. The fourth part is life cycle costing, and this is where we get into when does it make sense for us to repair versus replace or rehabilitate an asset. And then finally, how are we going to fund all of these activities that we want to do with our assets in order to provide our customers the service that they want. So the asset management ties to water loss are pretty strong. We take away from the asset management process that data-driven decisions are really important. And we'll focus a lot more on that in webinar 3 of how you use the data from your system to drive decisions on what to do to reduce water losses. It can also help you with more strategic selection of pipe for replacement. So rather than going in and replacing a whole big swath of pipe or a certain area of pipe or certain type of pipe, you can actually be very strategic, and it can save you a lot of money if you can really strategically select those pipes for replacement based on your data. You can also use it to have a more strategic deployment of leak detection strategies. So thinking about what's the best expenditure of funds to achieve the greatest results I can with my leak detection strategies. And again, that will be discussed pretty heavily in webinar 3. And then examine the potential to reduce or eliminate the need for additional resources. So, maybe you're looking at putting in a new well and need treatment for that well, but it turns out if you reduced your water losses significantly, you could avoid having to put in that new resource or that new well. So that could save you quite a bit of money if you can look towards things like that. So sometimes you can look at the potential that maybe you can avoid having to spend money on a particular asset and make the case there. So a poll question, or whether or not you're practicing asset management. So if we could go ahead and open the poll. Okay, so you have your choice of selecting which response best fits you. If you're not representing a system, you can either choose answer A or E. So I was not aware of asset management before the webinar. We've done a little bit. We haven't really tied it to water loss. We've done a lot, but we haven't tied it to water loss. We've done a lot, and we tied it to our water loss program. I was aware of it, but my system doesn't practice it. So choose the answer that best reflects where you are right now with your system and what your asset management practice is like.
Okay, we still got folks clicking in, so I'll wait a few more seconds before closing the poll. Okay.
All right, so we have many people who are aware of it, which is kind of nice. If we would ask this poll question a few years back, I think that answer would be a lot lower, where people weren't even aware of it. We have two groups, about 20% of us, that have done a lot. Some have tied it to water loss and some not, but that's really good to hear that we are starting to see a little bit more asset management practice occurring. So that's really good to see. And then 11% not aware of it. So I might recommend that if you're in that category and you want to learn a little bit more, there's quite a bit on the EFC Network website about it. And you can always contact us about where to get resources and whatnot to learn a little bit more about asset management. Okay, so we can go back to the slideshow now. All right. So the third factor is reducing pressure. So again, pressure has different effects on unavoidable losses. If you increase the pressure above what you're operating now, you will increase the background leakage rate. And if you decrease the pressure, you will decrease the background leakage rate. So it has both impacts. And depending on how much background leakage you have, this can be very dramatic. There are certain parts of the world where they've had unbelievable reductions in water losses by reducing the pressure. Places where they've had maybe not the best excuse me, not the best construction, long run lengths of pipe, and they've had a lot of background leakage, and they've dropped the pressure either all the time or just at night, and they reduce that background leakage quite a bit. You can also have a similar effect on your hidden losses. If you reduce your pressure, you will also reduce the flow out of those hidden losses, the ones that you don't see. And finally, if you reduce the pressure, you'll actually get fewer breaks of the reported type as well, and fewer of the dramatic breaks. Now, there are some considerations with reducing the pressure. One is many states, if not all, have a minimum pressure that they require just for public health purposes, because you don't want the pressure in your pipe to fall too low, because then you might suck something into the pipe. So they usually set a pressure minimum of possibly 20 or 30 psi. So you need to make sure that you're well above that minimum pressure that you need to make sure that you're maintaining public health and safety with your pipelines. But what we're talking about is you don't need to be maybe up around 80 or 90 psi. Maybe you can drop it down. But what you want to look at is your particular system. You want to see if you have, one pressure zone or many. You want to see if you might be able to reduce the pressure in a given pressure zone or throughout the whole system. You might want to think about, could you reduce the pressure at night? Again, you have to maintain that minimum pressure, but is there a way to reduce a little bit of the pressure at night to reduce the losses that occur then? You have to look at your system and see how realistic it is for you. Do you have pressure reducing valves in your system? Do you have pumps that can be throttled, using variable frequency drives to change the pressure? Or would you actually have to swap out your pumps or do something else to reduce the pressure within your system? And then how automatic is the control of your pressure reducing valves? Like, it may not be that easy for you to reduce pressure at nighttime if you don't have automatic controls on your valve. So you do have to look at your system, but it's something you definitely want to investigate. If you're running at a relatively high pressure and you have a lot of water leaks, you may be able to reduce that somewhat by reducing the pressure in your system. So at least take a look at that and see if it's a possibility within your system to have an impact with pressure reduction. You do want to make sure, again, that you're maintaining the minimum pressure and that you're providing enough pressure to make sure that the customers are getting what they need at their household. So we have a question now about pressure management. Do you do anything with pressure management in your system? So your choices are, and you can check all that apply, you've reduced pressure throughout the system to reduce losses, you've reduced pressure in some pressure zones to reduce losses, you've reduced pressure at night, you've experimented but not fully implemented it yet, and it does not apply because you do not represent a system, or you've just never done anything along the lines of pressure management. So choose the one that best fits your situation, or choose the ones that best fit your situation if you've done more than one of these things. Go ahead and click. Okay, so we haven't done a whole lot with pressure management. There's a few that have experimented, a few that have reduced it in some pressure zones. So we're not doing a whole lot with pressure yet. I'm not terribly surprised because I don't think the practice of pressure reduction is all that commonplace in the United States, but it is becoming increasingly more common throughout the world, where people are using this as a very good technique to address those background losses, because it's really one of the best ways to take care of that particular problem. Okay, we can go back to the slideshow now. Okay, and then finally our last strategy is finding hidden leaks. So if you look right there, this was a hidden leak that we found through leak detection practices, and you can see in the circle there, you might be able to just notice the water shooting out of the hole in this particular pipe. One of the things that people say is, are there really hidden leaks? Are there really leaks that we're not going to find? And I would argue that yes, there are leaks that you won't find, at least not for a very long time. because we've done some work in this area trying to figure out whether leaks would always surface and how many were actually observable versus hidden. And we even watched a couple of leaks that were very low volume leaks for a number of years to actually see if we would ever surface. For, I think one was 2 years and one was about 1.5 years before we decided to finally fix them. And they never did surface, never caused any problem. There would have been no way you would have known it was there without looking for it. So the kinds of things that keep them hidden are stuff like fractured bedrock or highly permeable soil, or other things like water going into a drain or a sewer. We actually had one where the water pipe had a hole in the bottom, and it had actually drilled a hole in a sewer pipe that was down and over from it, and there was a hole in the top of the sewer pipe, and the water was going into the sewer. So until something catastrophic happened to the sewer, we probably wouldn't have found it because it wouldn't have caused a sinkhole. But eventually it might have caused a problem in the sewer pipe, and we probably would have found it that way. But it's the kind of things that you're not necessarily going to find soon, or at all maybe. So how do we find them then? Well, we have to proactively look for them. They're not going to show us that they're there, so we have to go and look for them. And why might we want to go look? We want to reduce water loss. We want to prevent a catastrophic failure. You see some sinkholes in the pictures on the right, or you see a very deep hole that we had to make in the pavement on the left. So we want to try to prevent a catastrophic failure. And again, we sort of talked about this earlier, that if you have a small hole in a pipe, it can lead to a big problem later on. So we want to try to prevent those big problems by fixing the problem when it's a very small thing. It will help us increase our system integrity. Also will help us increase the life of our assets. If we fix things when they're very small holes, we can keep that pipe in service longer because we can keep its structural integrity intact. So it can help us reduce the overall cost of managing our assets if we actually start looking for our leaks. There's two different methods of looking. There's active listening and passive listening. Both of these rely on leak noise as the primary way that they're going to go find hidden leaks. Smaller leaks have a higher frequency than larger leaks. Leaks on metal pipe are louder than plastic pipe. Smaller leaks are louder than larger leaks in general. And then transition in pipe materials and fittings can muffle the noise. So we kind of have these basic noise factors that we try to apply to our pipes, and this is what helps us go look for noise. We have some concerns. It's not as simple as just going out there and listening, because continuous usage by a customer can also generate a noise that can be similar. Traffic noise can interfere and make it very difficult to do a leak detection survey. And electrical equipment can also sometimes cause a noise that interferes with our ability to tell where leaks are. And then one of the biggest things is we need access points to hear the noise. So we have to have something connected to the system, like a valve, a meter, a hydrant, that we can tap onto and hear the noise that the pipe itself is making. So we need to have those access points. And if you think about the fact that plastic pipe doesn't transmit noise as well as metal pipe, if you don't have a lot of access points and you have a lot of plastic pipe, it can really make it very, very difficult to do leak detection because the noise isn't going to travel far enough for you to hear it at each of those access points to the system. So you can miss some leaks that occur in a long run of plastic pipe if you don't have a lot of those connection points to be able to hear it. So if you do active leak detection, it's taking a person. It could be your staff member or it could be a contractor, somebody that you hire, and they would just walk along the system and they would listen at hydrants, meters, valves, and see if they hear any noise. And they will mark down where they've heard a noise, and they'll try to mark down if they heard a noise at 1 meter, then they listen to the next one, or if they listen to one hydrant, they'll listen to the next one and see if the noise is between those 2 points. So could they hear it at both places? And if not, they might pick a meter and a hydrant, or a valve and a hydrant, or some other combination of things to try to bracket where the noise is between. They'll mark that down, and then they'll keep doing the rest of the survey, and later on they'll have to come back and do what we call pinpointing the leak, and we'll talk a little bit about that process in a minute. But we want to have we want to think about, for this particular style, we have to have somebody who's highly skilled and trained to be able to do this, and it is very time and labor intensive. Passive leak detection kind of takes the initial part of the person out. The person will have to come back later on pinpointing, but initially it will do the listening for you, and it's either something that you permanently deploy, which is more like the situation in this picture, or it's something that you temporarily deploy, which is these pictures, or something that you could do either one. This has a magnet. It could be put on a valve and taken off. And essentially what happens is the device listens in the middle of the night. It listens for the noise at, say, 2 o'clock in the morning, and then if it hears a noise, it stays on. If it doesn't hear a noise, it shuts off for the night. If it hears a noise, it'll come back on at 3 a.m., listen again. If it hears a noise at that point, it will listen again at 4 a.m. If it hears a noise then, it'll go into alarm mode. And then it takes a person to come back and kind of pick up the alarm signals, see what equipment is in alarm, and then determine which 2 points seem to bracket the noise or where the noise seems closest to. And then you have to follow up with those alarms. Just because this device or that device or any of these devices goes into alarm mode doesn't necessarily mean there's a leak there. So it does take staff to follow up and make sure there's a leak. So when you're considering active or passive, neither one is a panacea. Neither one will find everything you're looking for. They have pros and cons, and we'll talk a lot more about this in webinar 3 about why you might choose to do one or the other. In the first case, active listening, you're paying more for the person who's going to look around. In the second case, passive, you're paying for the devices. And it depends on how long the devices stay in service and how you use them. You know, whether or not it's cheaper for you to use a person or the devices. So what is your experience with leak detection? We have another poll question. Whoops. So have you done any type of leak detection? Have you hired a company to do leak detection? And that means active leak detection. Hired a company to walk around and do active leak detection. Hired a company to do passive leak detection. Did you buy equipment to do active? Did you buy equipment to do passive leak detection? Or have you never done leak detection, or you don't represent a system? So take a moment and just pick the ones that apply. Okay, so we have many that have never done leak detection, 68%, and then we have some that have hired somebody to do leak detection, and some that have bought equipment to do it with their own staff. And again, we'll talk a lot more about this in webinar 3 about how you make those choices about what you're going to do, you know, which of these strategies to apply and how to apply them to your individual situation. Okay, if we could go back to the screen. Okay, so one last thing about finding leaks is water is only saved through fixing leaks, not through finding them. So really think about the capacity you have to fix leaks. So if somebody goes out and finds you 30 leaks, could you actually fix them? Do you have the staff, the equipment, the time, the resources to actually invest in fixing the leaks? Because if you don't have the ability to fix the leaks, it's not worth investing in finding them. So that's something you're really going to have to consider as you move along, that finding leaks is not saving water. It's fixing the leaks that's saving water. So when we get into pinpointing, one of the things we think about is, you know, where's the leak located? This is actually a picture that I took when I was doing some asset management training in Puerto Rico. And I was walking along and I saw this water bubbling up through the street, and you could tell that there was a leak in the pipe. But you don't know where the leak is. The leak might be right underneath this, but it might not, because water is going to seek the path of least resistance. It could run along the pipe and then come up at another point. So you can never be absolutely sure that when you see the leak surfacing, that that's where the actual leak is occurring. So we have to do what's called pinpointing the leak. And we use this on both ones that we can observe and ones that are hidden. It's even harder with a hidden leak because you have no clues whatsoever. But in both cases, we want to have the ability to pinpoint where the leak actually is occurring. So why might we want to do that? Is it's going to save us a lot of money and time by reducing the amount of excavation we have to make. So if we can have a nice small excavation like is shown here, it can save us a lot of money instead of having to dig up a whole big section of the street. That could save us a lot of money and time. There are tools that you can use, like this ground microphone, that will help filter and amplify the sound. You can go along on the surface, when you kind of know approximately where the leak is occurring. You could use that to pinpoint the leak more correctly. And there's also a more sophisticated approach, a leak correlator. And this is something that you can use if you kind of know where the leak is between. You can put a correlator on 2 points that connect to the system. This is showing 2 valves, but it could be a hydrant and a valve or something else, some other combinations. And you're trying to bracket where the leak is. So you put one device on one side of the leak and one device on the other. And then you have this correlator that will, you'll feed in the pipe diameter, type, size, and the length. And then this will calculate how far the leak is from each correlator. So it'll say it's L distance away from this one and L plus N distance away from that one. And you could mark the spot on the ground of where the leak actually occurs. And if you have good data about the pipe type and size and distance, it will give you a very accurate description of the leak. If you don't know so much of that information, it can be a little bit challenging because it'll put it off because you put the wrong pipe type or size. But this is a really good piece of equipment to help you locate those leaks. It is expensive and you need some training, but it could pay for itself in several different big excavations. This will pay for itself by limiting the size of that excavation. So keep in mind that although it's expensive, you can save money in the long run that can help pay for it. So we want to match our approaches to the type of loss that we have. So we go back to our unavoidable, our detectable, and observable. So what we're going to do with our unavoidable loss, we're going to do pressure reduction. We want to reduce the number of joints and fittings in our pipe. And then occasionally we'll have to do main or service replacement when the background leakage gets too bad. For unreported leaks, we'll use many of those same techniques, except we're going to add in proactive leak detection for this type of leak. And then finally, for the last, the observable, what we're really interested in is improving our speed of repair and trying to get those repairs done faster to cut down on the water loss that we have. Strategic deployment of those 4 different strategies and how you make choices within your own system will be the focus on webinar 3, like what considerations you have, how you should make those choices, what kind of information you need to collect. That's what we'll talk about on the next webinar. So to sort of finalize the discussion, we'll talk a little bit about doing things in your facility. Develop a team, people that can help you get this done. Complete an AWWA water audit to try to see what kind of problem you're actually having and how bad it is. Once you've done the audit, look to see, is your problem real water loss? Is that a big issue for your system or not so much? How big is that water loss problem? Because that will feed into the strategies for what you do when you know how big of a problem you actually have. Then you want to examine each of the 4 methods of reducing real loss. So how quickly do you repair breaks when they're identified? What's the length of time that it typically takes you? What could you do to improve the speed of repairs? Could you get more staff, more equipment? What could be done? Do you currently practice asset management? Have you considered ways in which you could be more strategic with your pipe replacement, which again, the more strategic you are, the more money you save, and that can be poured back into your program, your system. What pressure do you operate the system? Is it a very high pressure? Is it a moderate pressure? Do you have any opportunities to reduce the pressure? Could you do that all the time? Could you do it at night? Could you do it within pressure zones? So just kind of investigate, what is the operating pressure of your system and what can you do about it? Do you have any indications that you're losing a lot of water to hidden leaks? I mean, if you have a lot of real water loss, but you don't experience a lot of observable leaks, that's a good sign that the loss is hidden as opposed to being able to be seen. So that would tell you that maybe looking for leaks is a good thing to do. But you have to ask yourself, could you fix those hidden leaks if somebody found them? Would it be possible to fix them? And then finally, just tune into webinar 3 to learn more about how to figure out within your own system, how to think through that process of what makes sense to apply to my system. Which of those 4 strategies or what combinations of those 4 strategies makes the most sense for my system. Wanted to add in a poll question, our last poll question, to see if you're interested in any assistance with the other types of services that we provide. So we have asset management, rates and finance, water system collaboration, multiple funding, or energy efficiency. And if you click on any of those, we'll follow up with you to see what assistance you need. We did not include the water loss because we'll follow up with you separately on the water loss topics. But if there's any of these other topics that obviously weren't the focus of today's webinar, you can select those and we will follow up with you.
Okay, wonderful. I'm going to give folks a few more seconds. Seems they're still clicking in. Okay, I'll close the poll at this time.
Okay.
And before we get to our Q&A portion of our program today, I'm going to send you all a link to an evaluation survey. And if you could just take a moment and fill it out and let us know your thoughts about today's webinar, they'll help us for future programming that we do. We do thank you in advance for that. This link will also be sent to you in a follow-up email after our webinar today.
Okay, and I'd also like to say that, I know we don't have a lot of time for questions, so that we will, if you've typed in a question, we will answer those questions and get them back out to everybody. So if you've typed one in and we don't get to it, that's fine. We will send you answers to that, and we will also send you access to resources for water loss as well as a follow-up to this webinar. And then just let you know that March 31st, we're having our part 3 of the water loss reduction series. And then we have a special webinar. If you're interested in asset management or are doing any asset management, there's a special webinar. We don't have the exact date yet, but it'll be between April 22nd and 24th. It's an Ask the Expert webinar where we have a premier asset management professional from New Mexico who'll be visiting us, and we're going to open up a webinar to allow people to ask him questions. It's kind of a unique opportunity to ask somebody who's really engrossed in this, because New Zealand is probably the best in the world at asset management. So just kind of get advice and input from him. So keep your eye out for that. We will send announcements out on that. And we want to thank EPA for providing the funding for this project. And I have my contact, and then one of my colleagues, Don Null, if you have questions, following this webinar, you can always send them to us separately if you didn't get a chance to type them in. So we just have a
Heather, I can't hear you, Heather. Maybe you muted yourself? Sorry, everyone. Just give us one moment. We seem to be having some audio issues. Heather, are you there?
I'm here.
Okay, good. We can hear you now. Marvelous.
Oh, oops, was I gone?
Yeah, you were gone for a few seconds after you mentioned the contact information.
Okay, so anyway, so I think we have a minute or two if there's any questions that came in. I don't know if anybody has typed in any questions as we're going along.
Yeah, we've got a couple questions. Our first one comes from Janice Becker, and Janice writes, our most expensive losses are due to meters freezing and breaking in winter, which allows massive water loss that is hard to find because it is just going down the sewer line or into aquifers, and we can't even bill for it because the meter was broken. Our board wants remote read meters. Do you think this will really help when customers are not willing to shut off their water over the winter when they are gone? Would it be legal to force them to do so?
Well, I don't know about the legality, I can't say, but it's quite possible that you could have fines or penalties if somebody doesn't do it. So I would think that you could have a policy within your water utility to say that if a customer chooses not to shut off their water in the winter and the meter freezes and that causes a water loss, that there could be a fine or a penalty assessed to that particular customer for having, cost you all that water. So you might want to investigate the ability of your particular water system. I don't know whether you're municipal or like a homeowner style water system, but you could probably adopt policies that would require some kind of penalty. And the remote read meters, perhaps they would tell you that the meter is frozen. I'm not really sure how good they are at dealing with a freezing situation, because it sounds like the problem is the water's not moving and it freezes in the meter, and I'm not sure whether the remote read meters will help with that particular issue or not. We might have to look into that a little bit more to see if that would make any difference or just give you information. Perhaps it can tell you that the meter's frozen. I'm not 100% sure on that, but I think the better way to go is really think about a policy and some kind of financial penalty if you choose to not shut off your water in the winter and then the meter freezes and you have a problem, then the water system can assess some kind of penalty to that customer.
Okay, thank you. Our next question comes from Thomas Knight. Thomas wants to know, what is the average water loss percentage you've seen during your study? 10%? 20%?
It's really a hard question to say because people evaluate that number so differently. Like if you just take the water produced minus water sold number and call that water loss, what you end up with is numbers anywhere from people reporting about 10% up to about 80%. And when I hear a number like 80%, I picture either the ground is completely soggy because there's water everywhere, or there's something crazy going on with non-revenue water. So because most people don't do an actual water audit yet, we don't really have good figures for what that number actually is. So I think a lot of times I've gotten very crazy responses when I've asked systems the number, and they're not basing it on the right thing, which would be a full-blown water audit. I think when you get into actually auditing the water loss, it's a much lower number, probably closer to 10 to 30%. And much lower than 50 to 80%, which we've often seen in small systems. So I think until we get to the point where we really have everybody sort of comparing apples to apples, it will be hard to answer a question like that. And hopefully when people start using maybe the AWWA process and it's fairly consistent from place to place, then we can start looking at more averages of what's actually going on at the systems.
Okay, wonderful. Thank you. And then we have a question here from Mark Fenich, and Mark asks, the cost of the leak versus the costs involved to detect and create a system that can utilize leak detection need to be looked at, and in most cases it does not pay. The water will eventually find its way back to feed the system. Is it really a loss?
And I would say yes, it is. I've actually done quite a bit of thinking on the issue myself and convinced myself that it is actually in most cases worth looking, but you do have to be strategic, which again is what we'll talk about next time. You don't necessarily want to look in 100% of your system for losses. You want to be very strategic about what part of the system you're going to look. For example, we have portions of some systems that are much older than other systems, and they're experiencing a lot of the breaks. So you can strategically look at just those sections of the system instead of looking at all the pipe. So if you're strategic, you can get to the point where what you're doing is worth doing, because the catastrophic failures are so expensive that if you can prevent even a couple of those, it can pay for a whole leak detection program. So if you have a small leak that eventually causes the pipe to burst and it creates a big leak or a sinkhole or something like that, those repairs are very expensive. So you really have to consider that cost as well, not just the cost of water, because it is cheap to produce water in general. And so a lot of times it's not going to be enough of a cost concern to be the only consideration that you have. But with system integrity, keeping the pipe in service longer, preventing catastrophic failures, if you consider all of the cost and not just the cost of water, you can make a case for strategic deployment of leak detection, I believe. And I think we've come to the end of the official time, and I don't like to hold people over. So any other questions that we have, we'll be happy to look them over and write a response, and we will send the response to all of the questions to everybody who attended today's webinar. So we'll be happy to answer those, and any others that you have after the webinar, we're happy to take your question via email and answer it, and we'll share it with everybody if it's something that would be of interest to the whole group. I really would like to thank everybody for sitting in on today's webinar. We appreciate you attending, and we thank you very much.
Thanks, everyone. Have a great day.